Okay, alright. Since morning we are discussing on the public blockchain majorly, so now it's time to discuss on private blockchain. So Hyperledger Fabric is one of the most famous enterprise framework we can say in the industry, right? So I will not go again on the same concept what we have been going through since morning. So again the definition I will say like it's a single line. It's a shared distributed ledger. And talking about the characteristic like consensus, provenance, immutability and the finality. So what consensus it means achieving some certain state of the asset, and we define some kind of mechanism and using those set of rules or something we can say where we are managing the final state of the asset, that is the consensus. Provenance, what does mean the provenance? The provenance is if you are doing lot of operations and each operation will have as a history, so you can just check anything like whatever the transactions you have done in the past, you can just check and every participant in the network will have the exactly copy, and that's why they will be able to see the history actually, that is the provenance. Immutability, once data is added into the blockchain you cannot revert it, so that is the immutability, it's a temper proof. And finally it's a finality. Finality it means if you wanted to make any kind of the update, you have to make one more operation and that will be stored as a history. So those are the main characteristic of the blockchain: consensus, provenance, immutability and finality. Okay, talking about the distributed ledger. So ledger is nothing but a database and it's shared across the network, that's the distributed. Smart contract. So smart contract is nothing but just a business logic we can say. In the public blockchain also, every blockchain we have. Public blockchain is little different and private blockchain is little different. But the main core concepts are exactly same. Like we wanted to do certain business logics, so we can achieve using the smart contract. Next one is the again consensus. It's a achieving the final state of the asset using some sort of mechanism. So in the private blockchain we use Raft as a consensus algorithm in Hyperledger Fabric, and in the public blockchain we have multiple proof of stake and proof of work. There are a lot of actually. Okay, alright. So today we will be discussing on one of the use case. It is just a basic, and as per your business requirement, you can also have the exactly same. First, okay. Yeah, let's talk about the organization structure. So there are multiple stakeholders in the industry. They wanted to have some sort of communication between them. So let's take one example actually. There are three organizations, IBM, Lenovo and Dell. They wanted to have some sort of communication in the contractual manner. Like IBM is importing some kind of laptop from the Dell and maybe some other hardware from the Lenovo. So what they can do, they can just create some sort of network, they can define some policies, and using those policies they will be having some this kind of communications with them. Again, the communication is happening privately. There are multiple options. In the traditional way, they can just do just kind of centralized database and they can achieve the same thing. But there are certain conditions like if managing authority is doing some kind of temper with the database, they won't be able to identify it. So the same thing if we are using Hyperledger Fabric, the same thing can be managed with additional trust and transparency. So how we can do that? So let's talk about. Okay, there are right now on the screen you can see there are two organizations, and each organization has some sort of different kind of users. Some sort of policies, rules, and they will embed in some sort of configuration block. Once they form this network, like who can do what, who can create the agreement, who can approve that agreement. So again, I'm talking about just a simple agreement, so that there could be any kind of things actually. So they will just come together, they form the set of rules and they decided the rules like who can create, who can approve or who can reject, even who can renew. So those are all the business logics are there. So once they embed all the rules, they will start having the communication in the Hyperledger Fabric. So we have lot of layers of securities. First one is the permission plus private network. Permission plus private network, it means only authorized entities are allowed to communicate with each other. So that is the first layer of security. Means only IBM, Lenovo and Dell, whatever the users they are going to onboard, they will be having communication with the network as per the policy and the set of rules they define. That is the first thing. Second one, so IBM has a contract with this Lenovo and the Dell. So they have some different data, right? So Lenovo should not aware about the contracts between IBM and the Dell. So what that kind of confidentiality, they can again create some kind of medium, and they maintain one more layer of the security. So that's an additional layer actually, we can say. Those are the channels, we can say. Those are the medium having the communication. So again they will have this kind of set of rules, that is a smart contract. So who can do what and all, the validation will happen through the smart contract. Okay, so that is the second one. Another one thing, so there is a one case, these three organizations wanted to have a communication together, but IBM do not want to disclose only the price information. So that kind of additional security can be managed using the private data collection into the Hyperledger fabric. Okay. So in the traditional technology, one more thing we generally covers, like encryption of the data. Even the same thing can be done in the Hyperledger fabric as well. At the fourth layer, we can just encrypt the data, like highly classified or the confidential data, you can just encrypt it and put it there. Okay, so in the agreement, we will have some documents, right? So those documents are recommended to store on some sort of file system or maybe S3 bucket, there are a lot of other options. So we can store it anywhere in the data, Hyperledger fabric or any kind of blockchain, they don't care about the data. They just want a key and the value, right? So value could be anything, it's a binary data or JSON object, or it could be anything. But storing this file system, we have some sort of limitation on the Hyperledger fabric block size and the transaction size. So that's why it is recommended to store the data. So it's recommended to store the file data or document onto the some S3 bucket or some other file format, and we can just store the content hash of that data to the blockchain. So any point of time, if you wanted to verify, if someone has even tempered that record, they will be able to identify it easily. Okay, we'll discuss again on the Hyperledger fabric. Why only Hyperledger fabric? Why not other framework? So again, it's a permission plus private blockchain network. It's having shared database. Actually, it can be replicated across the different node in the participant. One more thing, business logic can be embedded in the form of code. So whatever the business logic, who can approve your approve your agreement, who can renew the agreement, that all the logical use cases can be embedded into the form of code, and you can just implement it. Next one is the privacy. As I mentioned, like three layers of the security we already have. It can be the privacy can be maintained either first in network layer, second one is the channel layer, third one is the private data collection layer. Okay. Talking about the most important component in the Hyperledger fabric. So first one is the asset, next is the ledger, third one is the identity. Generally we use X509 standard certificates. It's the PKI actually, public infrastructure. We will be going through one by one. Okay, alright. So the main component of the Hyperledger fabrics are the organization. First is, that is just the logical representation of that particular network component, network stakeholder. There is nothing like physical, but some of the services are there which are indirectly represented into the organizations. That one of the service is the peer. Peer actually holds the smart contract and the ledger. So what does mean by smart contract? It's just a business logic. Peer will manage that. Another one thing, peer will have the ledger as well. What exactly the ledger, will go through it again. Orderer. So we have some additional mechanism in the Hyperledger fabric. Orderers are responsible for creating the block. When they get the transaction, they order chronologically and just form the block and send block to the appropriate peer participant into the network. Fabric certificate authority. Certificate authorities are responsible for distributing the certificate. So it's not like the traditional technology. This Hyperledger fabric don't understand the username and the password. They do the validations using this public infrastructure component. That is a public key, private key, and the certificate. So that's why certificate authority plays very important role in the Hyperledger fabric. Each stakeholder or organization will have their own certificate authority. because they don't trust on each other. So that's why whatever the participants in our organization we have, they will get the certificate from this their own certificate authority only. Another one thing, membership service provider. Membership service provider is one of the important concept. So who will be responsible for doing what? So within the organization, when they comes together and form the policies, they will decide like which organization is responsible for what kind of operation, administrative operation, normal operations and all. So they will embed, and here the membership service provider plays a vital role. Okay, so talking about the transaction flows and all, so when we invoke some kind of transactions, I will let you know how exactly the transaction flow works. So in the document management technology stack, I will be using like front end for the React.js, API writing Node.js I used, and MongoDB also I am using for storing the username and the password. So you might be wondering, Hyperledger Fabric don't understand these things, then how why we are storing username and the password. So right now the users are not mature enough to handle this public and the private key. That's why people generally prefer to store this credential, crypto material, maybe somewhere on the secure at the API side only. An organization will be responsible for holding that, and they will give username and the password. They will give the interface to create the username and the password on the web of the user, and they can just interact with the network. Right side there is a fabric network, so actually where all the components would be there. If we have two organizations, each organization will have some sort of PS services, and inside the PS services we'll have smart contract and the ledger, and finally the explorer. So explorer is just for visualizing our chain of the blocks, how exactly looks like. Okay, so the first component, asset. So we were talking about the contracts agreement, right? Asset is nothing but just kind of tangible or intangible, anything. So the car is one of the asset having some kind of information, color, make, model, owner. So in our use case, agreement itself is the asset where we are embedding all the information. Who is the first party, who is the second party, what are the documents associated with that contract, who is doing what. So that all the information we are storing in the form of asset. And it's not about the document or something. You can logically you can store anything onto the Hyperledger Fabric as a document, asset. Okay. So next one is the ledger. So when we talked about the peer, so peer will hold the smart contract and the ledger. So ledger is nothing but the database. Actually data is getting stored on the ledger. So in the Hyperledger Fabric network, we have two things in the ledger. First one is the current state database, and second one is the chain of the block. In the current state database, always there would be a latest information. So let's consider I created a contract C1 with party P1 and P2, and having right now the expiry date maybe after 1 week. Okay, so current state database will have that information. I created this agreement, and the chain of the block there would be one transaction get recorded, and the latest value will have this information. But when I am renewing the same agreement after 1 week, the latest, because I will be updating the same contracts and the ID would be exactly same, but data is little different because the expiry date will get extended. So in that case, current state database will have the latest value, and chain of the block will have one more transactions. It means in the ledger, history is also getting stored and latest value is also getting stored. So I will show you exactly when we create the agreement. Okay, so in the blockchain we can see these blocks are interlinked with each other. It's having information like multiple transactions would be there in the blockchain. So this B1 having 4 transactions, B2 having 3 transactions, B3 having 2 transactions, each have other information, and these blocks are linked with each other using these hashes, because hash is getting used for creation of the next block hash. So that's why they are interlinked with each other. One important thing, there is no mining process into Hyperledger Fabric. It's a permission plus private. So only authorized entities are doing this operation. So when they initiate a transaction, it will get automatically added by doing the validation through the transactions flow. Like endorsement phase is there. There are different phases actually. We'll go through it. Okay, we talked about the blockchain, right? Now let's consider one single block. So it will have this information. H is the header. The different transactions are there, and metadata is also there. So inside the header will again have other information. Current block hash, previous block hash, and the block number. Okay, talking about the transactions. So I as a user from organization 1, I am doing some transaction creation of the agreement. So in that case, it goes through some certain process. It's directly never get committed into the ledger. they need to get some kind of approvals from the organizations. Once they get the approval, then only this transaction will get committed into the ledger. So that's why we have S4 is the signature, P is the proposal response, R is the response, and finally E is the endorsements. Those are the validations we can say. Okay, I think you are already aware of the PKI, right? Public key infrastructure. So it's having different components: digital certificate, public key, private key, certificate authority, and finally certificate revocation list. The Hyperledger fabric is one of, Hyperledger fabric is using the same PKI. It's not something different. PKI is the normal general concept, everywhere it gets used. So the same thing is getting utilized in the Hyperledger fabric as well. And the validations, signature creations we are doing the exactly same how we do for the PKI. Like when you hit any kind of domain, right? Google.com. So how to secure communication happens. So first it will so they will do the acknowledgement from the client to server, and finally they will sync one kind of key, symmetric key, and finally they will have communication with encryption and decryption. The same thing, most of the validations are happening in the Hyperledger fabric with the same manner. Okay, the certificate, I just wanted to give one, how certificate get created. So let's consider so when user requests a certificate to the certificate authority, main admin user is responsible for registration of that particular user. Because this is the private network, no one directly can enroll with certificate authority. Admin will just first register that user, and that registration, once it is done, then user can request for the enrollment and he will get a certificate. First he will just include this information and give to the certificate authority. So certificate authority will validate whether this admin user has already registered him. Once it is done, he will create a hash of the above information. Okay, we get a hash, right? After getting a hash, the certificate authority uses private key and encrypt this data and put it as a digital signature at the bottom. So this is the X509 standard certificate. Now, once certificate get created, anyone can validate. Let's consider I got this certificate. How I can validate? I will again do the same thing. From the top information, I will create a hash. I will get this hash, and this information again have the certificate authority information. If I am trusting the certificate authority, I can just say if these hashes are equal, the certificate is valid. So how I can do that? At the bottom there is a digital signature. I can just decrypt this information using certificate authority public key, because it's got encrypted. This hash is encrypted using private key of the certificate authority. So I can just decrypt it and get a hash. If these both hashes are equal, it means the certificate has not been tampered. And if I trust the certificate authority, I can say this is a valid certificate. The same validation is happening throughout different phases of the validation. So I will go through the demo actually now. Okay, alright, so it's just a basic application, CRUD operation, we can say. It's not something, but you can utilize it anywhere, and as per your business use case, you can use it. So I'm going to create one contract. So I already have two different organizations, and they are doing, so this all the set of rules and everything I already created. I created one medium in the form of channel, and deployed one smart contract as well, where I can just create the agreement data. So I will just show you this ledger, how exactly looks like. So ledger I have in two-part, current state database, and second one is the chain of the block. Okay, so I'm just doing it. I'm just adding random data. Okay, I'm just uploading one sample document actually, test document. Okay, this agreement just got added. When we are viewing it, it's having this information, and actually we are fetching this data from the chain of, blockchain itself. So it's having this information. So here is the agreement file. So when I click it, so we will just redirect to the S3 bucket, because we are storing this document on the S3 bucket, and in the current state database, that is the one part of the ledger. I will show you how this looks like now. Okay, this is the collection where we have all the agreements. Now you can see this is the asset I was talking about. It's having different fields, like how many approvals are there inside the approval, like what is the action they have taken, agreement ID, document type, description, any other information. It's totally up to you how you wanted to implement, but it will have all the information. And this is the latest state I was talking about. In the Hyperledger fabric there are two things. First one is the cows DB and second one is the level DB. So these two options we can use for storing the current state database actually. So right now I am using cows DB as the current state database, and so we can visualize this data actually in the form of this JSON object. It's having different value in the first party, second party, status, dates, some important dates are there, contract type, yearly, daily, whatever it is there. And the same thing I wanted to show on the chain of the block as well. So this is the explorer actually. So let me show you. Okay, so this is the explorer where we can just visualize all the chain of the block. So total 21 blocks are there and the 21 transactions, because I was just triggering the transactions after maybe 2 seconds per. So that's why we have limited, and it's having other information, blocks, some other transactions by organizations and all. So let me show you the transaction actually. So this is the chain of the block where actually the data is getting stored. Current state database will have only latest value. So you can see in the Hyperledger fabric transactions are little heavy compared to the public blockchain. It's having lot of other informations like signatures, certificate, lot of other information we can see. Transaction ID is at the top. Proposal payload is there. Creator who has created the transaction. How many endorsements are there? So this is the endorsement I was talking. Endorsement is nothing but approval. Which organization does the approvals we will be able to see here. The other information is there, and finally we have read set and the write set, right? So inside the read set and the write set, actual information we will have. Yeah, so this is the agreement actually. Maybe it's little blur, but at the bottom we can see this is the JSON object representing the this contract, actual contract. If I'm making one more transaction on this, one more block will get added, and that current state database will get updated with the latest value. But the previous history we can just get using this chain of the blocks. There are a lot of other APIs are there, so where we can get all the history of the previous data. So in the Explorer actually we can see different information, dashboard, network participant, how many participants are there, how many blocks got created. So it's totally up to you, like what kind of information. Even you can change this implementation as well if you want. Number of chain codes, number of channels. Right now we only have 2 organizations, that's why we're able to see only minimal participant. But so it is totally depends on how your use case you wanted to implement. In the supply chain domain, there are a lot of participant stakeholders. People generally get confused like how they architect. It's really important to architect the application actually, how many participants should be there and all. They have to be very careful, because in the supply chain there would be a lot of suppliers, right? Thousands of suppliers. We cannot have hosting for them. They definitely will never wanted to pay for the infrastructure. So the manufacturer will be responsible for giving this, managing this Hyperledger fabric network. So they can just logically segregate them at application layer itself and manage the data. Okay, so one important thing on the transaction flow I wanted to discuss once last thing. Okay, so right now for clearing one of the concept, I have taken third organization as well here. Okay, so there are 3 organizations. So this is the transaction flow, how it is in the Hyperledger fabric. Initially, first user invoke any kind of transactions. They will sign the proposal. Sign the proposal will have information like what kind of data wanted to add, what is the channel name, what is the chain code name, that is the smart contract, and they will initiate the transactions. So peer in the same organization will just send the transaction to the other peer for approval. So while deploying the chain code, we decided how many approvals we require to submit the transaction. So in that case, this peer will get sufficient approvals from the other organization. At this phase, the data will never get committed. So at this endorsement phase, they will just validate whether this user is authorized to perform this action or not, whether he has valid signature and all. This validation happens, and finally this signed proposal, each peer will endorse the transactions and send back to this main peer, okay, in the organization. This peer will just collect all the endorsement and finally send to the orderer. Orderer just chronologically order these transactions and create a block and finally broadcast to the all the necessary participant. And finally, these transactions gets committed again by doing the validation whether this transaction has sufficient approvals and not. Is endorsement is correct, that validation again happens, and finally data get committed to the ledger. So these are the different steps involved. First one is the endorsing phase, second one is the committing phase, third one is the ordering phase. Okay, so endorsement, ordering, and finally commitment. So these three phases combiningly we call as consensus. In the Hyperledger fabric, we can achieve the consensus using these three stages. First one is the endorsement, second is the ordering, and third one is the commitment. Any question on this? If you understand this transaction flow, you almost 80 to 90% already know the Hyperledger fabric. So you have to understand this Hyperledger fabric transaction flow. Yeah, please.
Can we say that is Hyperledger fabric better than Ethereum?
Okay, so both of the frameworks have their own potential. So comparing public to the private, it's having different features, right? Private have different features, public having different advantages. So I think comparison between two private framework or two public framework, that makes sense. But private to public, so it totally depends on your use case, what kind of use case you wanted to implement. And accordingly you have to decide whether you wanted to go with the public or private. But comparison, I don't think we can do.
I have one question.
Yeah, please.
How can we add a pluggable consensus in Hyperledger fabric? Can you some?
Okay. Okay, all right. So previously also, initially when Fabric version 2.x, actually we had multiple options. First one was the Zookeeper Kafka, that was the pluggable consensus mechanism. We were achieving this state of that particular asset across the different network ordering nodes actually. Now we have Raft that is officially supported, and the Solo and the Zookeeper Kafka, they have removed it. So one more consensus algorithm they are going to support. So you can use any one of them. Raft is right now official, and the BFT they are going to support. So it's totally up to you which one you wanted to use actually for doing this kind of.
Actually, I wanted to ask you that if I wanted to write my own consensus algorithm for some research work, and then I wanted to add that for Hyperledger fabric to check something like interoperability in between different blockchains in the Hyperledger fabric under the same umbrella of Hyperledger actually.
Yeah, you can do it actually, but you have to follow all the constant actually they are already following. This PVFT, BFT, they had a plan actually since long. Because of some lot of complexity, they are still on. It's on the development phase itself. It's on the roadmap, and in the 3.0, I think they are officially going to support. It's in the beta right now. But yeah, you can have probably you can tweak that PVFT is PVFT or BFT.
Thank you.
So I think this question. So actually in Hyperledger now is a modular architecture. So actually in Hyperledger is a modular architecture. Everything is pluggable. So for example, there is a consensus one library folder in the Fabric source code, and there are multiple implementations. So you just need to, it's a kind of interface level implementation. So some interface is there. You just write your own implementation and call this interfacing. You'll be able to do it. But it's very highly technical, but it's doable. Like how they added the Solo and then Kafka and then Raft and now BFT and Mir BFT and other stuff. Similar, you can write and just implement the interface of consensus library. Is there?
What is Hyperledger and what is Hyperledger fabric? is Hyperledger and what is Hyperledger Fabric? Why it is called Fabric?
Okay, Hyperledger is set of technology. Actually, it's we can say broad umbrella, and under that Hyperledger Fabric is one of the framework. Under Hyperledger there are a lot of projects actually. Hyperledger Sawtooth, Hyperledger Arrowa, Hyperledger. There are multiple actually. Caliper is one of the tool actually. This Indy is there. This Explorer is also there. There are a lot of Hyperledger is just kind of umbrella we can say, and under that we have a lot of different technologies. This framework Hyperledger Fabric, Indy, Sawtooth, Arrowa.
Okay, thank you.
Thank you, Pawan. And if any questions, as I said, I will forward to speakers. And we are going to have a workshop on Hyperledger Fabric, and Pawan only I requested, and maybe we will discuss the dates and we'll come up with the final schedule. But we are going to have a workshop on Hyperledger Fabric.
Yeah, one more thing actually.
And
On
this
the
course is also available.
yeah, course, and actually from tomorrow I am going to deliver the same agreement management on the Hyperledger India chapter. So it would be almost 6 hours course. So whoever is interested, they can just join actually there. So we'll be go to the deep, because 20 minutes covering all the things is not possible. So we require a lot of time, and understanding a lot of things we require additional time.
How can we join it?
I think on
Kamlesh sir may share the details. And
Because Hyperledger India is
yeah. So Kamlesh is a general Hyperledger India.
So in Hyperledger India, we are doing many things. So first we are running one monthly LinkedIn Live, and Pawan is doing a this agreement management complete course end to end. And you can go and check the Hyperledger India LinkedIn page. You can find the event detail. And secondly, in the Hyperledger India, we are also setting up the different student chapter society in the different colleges. So if any college is interested, then connect us. We help to set up. So like currently we are setting up in Chandigarh and Bangalore and Chennai.
Yes. So Wiki page will help you to get the details. So thank you, Pawan, for
Thank
this
you.
wonderful session. And
Thank you. So it's not easy